All right, so the other day we left off doing our practice, and today I'm going to show you another level of ionic bonding. This is called ionic bonding involving polyatomic ions. Involving polyatomic ions. All right, what does poly mean? What? Multiple or many. So poly means many. I think you guys know what an atom is. It's the smallest unit of matter. So if you have many atoms, that's polyatomic. And in fact, what it means specifically is different types of elements. So two or more different types of elements bonded together means polyatomic. But then ion, what does ion mean? If you have an idea, raise your hand. Ion, what is an ion?
Is it something where it's a different number of electrons?
Different number
protons?
Different number of electrons than protons. So you can say your protons do not equal your electrons. Also, in a kind of basic form, an ion is something that's charged, right? It's either plus something or minus something. So ions are charged. So an example of a polyatomic ion is something like CO3 2 minus. So what that means is you've got a carbon, you've got some oxygens, 3 of them in fact, that are bonded to that carbon. And then you have, I'm going to put little dots here, 2 extra electrons here. So a CO3 2 minus, it means, remember when we made these compounds up above, our whole point was to make it become charge neutral. Well, that doesn't always happen. So just because things bond to each other doesn't necessarily mean that it's charge neutral, and that's when it becomes a polyatomic ion. What I'm going to ask you to do right now, while we're doing this lecture, go ahead and get your sheet out that you make your flashcards with, because it has all the list of polyatomic ions. And then I'd also like you to get out your periodic table. So I'd like you to have those 2 things out while we're taking notes. In ionic bonding, and by definition, it is a cation. Remember, a cation is a positively charged particle bonding with an anion. All right, so let's talk about naming. So, rules for naming. So we got a cation and an anion. I want to remind you of the rule for naming. If it's just an element, you just do the element name. And then for the anion, you do the element root. And then you add the ending IDE or "ide" to the end, right? Like bromide, chloride, things like that. So an example of this, when these 2 bond, it could be something like beryllium, bromide. Now, if the cation happens to be a polyatomic ion, what you simply do to name it is you do the polyatomic name. So if you had a polyatomic cation and it bonded with just a regular element, like you had that combination, it would be something like ammonium chloride. On your chart, do you guys see ammonium? It's the only positive polyatomic ion on there. It's on your polyatomic ion chart on the backside. Alyssa. Yeah. On the backside. Yep, it's on that one. It's the one that I'm asking you to make 12 flashcards, has the little asterisk by it. So ammonium is what? NH4 plus. Yeah. All right, what if the anion is also a polyatomic ion? What do you do if the second thingy is polyatomic? Well, it's pretty easy. Guess what? You don't have to change anything. You just use, again, the polyatomic name. So if it was just a regular element bonded with a polyatomic cation, so you could do, or anion, you could do like calcium. That's from our periodic table. And how about carbonate? Notice on your chart, carbonate is one of the polyatomic ions. It's called a carbonate ion. It's CO3 2 minus. You don't have to change the ending. You just simply leave it alone and use the word carbonate. And then what if you had a polyatomic cation and a polyatomic anion, this marriage? You could have something like ammonium. You just use the name. And then maybe sulfate. So there's 4 different ways to make an ionic bond. If it's what we call binary, it's just 2 elements bonded together. Keep the name the same, change the second one to "ide." But anytime you have polyatomic ions involved, it's pretty easy for naming. You just use the name. No changing at all. All right, now I want to show you how to go from the name to formula. So I'll just use these examples. Beryllium bromide. This is a refresher for what we did last week. Beryllium, what's the symbol? What's the charge? Got to find it on the periodic table if you have that in front of you.
It's BE.
BE, what's the charge?
2 plus.
2 plus, because do you guys see it right here in the second column? BE, 2 plus.
And then you want to do bromide?
Bromide. Okay, so it ends in IDE. That's a clue to you. Oh, I should look on the periodic table.
On that side.
And it's on this side, yep. You see BR, you're looking for bromine.
It's 1 minus.
It's 1 minus. So you've got BR minus. All right, to make the formula, you can just swap and drop the little symbols. So the actual formula for this is,
BE and then BR 2.
yep, I need 2 bromines for every 1 beryllium. You have a question? No? Okay. All right, let's do ammonium chloride. So ammonium, that's one you're going to have to trigger in your memory. You're going to be looking for it and looking for it on the periodic table. You're going to lose your mind because it's not there.
That's a compound.
It's a polyatomic ion. So look on your chart. What is ammonium?
NH4 plus.
NH4 plus. And chloride, it ends in IDE, so I look at my periodic table. Chloride, so I'm looking for actually chlorine. 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 I find it on the right-hand side. Remember, anions are on the right-hand side. Because I think what ends up happening when I find students start going cross-eyed because they can't find things. And they're like, I can't find it. So you start to, oops, thank you. You start to find things that are negative on the right-hand side. So here's chlorine. I want to remind you it has 7 valence electrons in its outermost shell. Therefore, it wants to gain just one more, so it can be argon-like. When you gain 1 electron, you are negative. All right, so ammonium is a positive, chlorine is a negative. How many of each do I need to cancel each other out? Just 1. So I just smash them together, NH4Cl. And remember, once they have bonded, they're now charge neutral. So I no longer have the superscripts. I no longer have the charges that are up above. Yep, negatives and positives go away because they canceled each other out. All right, now let's try calcium carbonate. Okay, calcium. Doesn't end in ate or ite, so it's probably not. Well, and remember, ammonium is the only one you have to memorize that's positive. All the rest are going to be on the periodic table, so you find calcium over here on the left. Here it is. It is in the second column. So the symbol is Ca. The charge is positive 2. And then carbonate. If it ends in ate, you should look at your chart, not the periodic table. You don't have one? We'll borrow one from. Do you not have one at all?
I turned mine to.
Oh, with the it's the thing to make the flashcards from.
Oh no.
I go on.
You don't have one of those? Uh-oh. Okay, I'll get you. Don't forget.
Nice.
All right, carbonate. When you find it, will you please yell it out? What is it? CO3, -2. Good. All right, so calcium's a +2, carbonate's a -2. How many of each do I need to cancel each other out? Just 1 of each. Again, so I just smash them together. CaCO3. Now I'm going to show you a tricky one. Ammonium sulfate is a bit tricky. Ammonium, we've already looked up that one. That's NH4+. Sulfate, it does not end in "ide", so I probably need to look at my polyatomic ion chart. And what is sulfate? Can you find it on there? SO4. What's the charge? -2, yeah. How many ammoniums do I need to cancel out my sulfate? I need 2. So how do I write that? I write it like this. I write NH4 in parentheses, and then I put a 2 on the outside of the parentheses. So this is kind of like math. You know when you're trying to multiply something, you put parentheses, or you factor something out, you put parentheses. It means you have double of something. So in chemistry, we don't put it in the front. We make it be a little subscript, and that means you have double the NH4s for every 1 SO4. I don't have to put parentheses around SO4 because I only need 1 of them. So polyatomic ions, folks, if you have the need to have 2 or 3 or 4 of them, you have to put them in parentheses and then put the little subscript outside the parentheses. And I want to remind you what you're doing here. You've got NH4 that's got a naked proton, and you've got CO3 that's got 2 spare electrons. And so ammonium's like, here, I'll be your little dance partner, and carbonate's like, but wait a minute, I got another electron. So ammonium is like, well, here's another ammonium, and then I'll be your little dance partner. And that is why you need 2 of the ammoniums for every 1 of the CO3s. And you can't do it without the parentheses. If you tried doing NH42, then that would look like NH42, right? Like if you didn't have, how do you show it's double? What if you did N2H8? N2H8, like you have double the nitrogen and 8 of the hydrogen. While that ratio is technically correct, it's not how it bonds. So it's not proper to do it that way. How about some practice? Let's do some practice. Is there any questions so far? All right.
Oh no, I'm really strong.
All right, I'm going to give you the name, and I'm going to ask you guys to do the formula. Eventually, I'll give you the formula, and you'll have to tell me the name. So you do need to be able to go back and forth, but I feel like the more challenging skill often is taking the name and making the formula. So let's do, I'm going to give you 6 practice problems. About magnesium bromide. How about calcium phosphate? Germanium? No, gallium. Let's do gallium. Gallium hydroxide. Just a note to self, hydroxide is one of those exceptions. It ends in "ide", but it's not found on the periodic table. It's a polyatomic ion. Almost all of them that end in "ide" you find on the periodic table, but this is one of those exceptions. How about potassium sulfide? Aluminum sulfite. Ooh, look how close those are. Let's do ammonium oxide. Ammonium oxide. All right, so find the symbol, find the charge, and do your little swap and drop and figure out how many of each you need. Challenges are, where do I look for it? What charge is it? Yeah, please.